Okay, hi, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. So today we will proceed on to into next part of matrix decomposition, which is the SVD or singular value decomposition. And yes, in this chapter I will explain what is the singularity value decomposition, and then to apply this theory into image compression, I will share with you a YouTube link on how we can see on how we can see the applications of the SVD onto the image. Alright. So yes, before I proceed to this all the symbols here, I would like to briefly explain about what is or what are the behind of SVD. Okay. So basically for the SVD, we will look into how we can how can we manipulate the vector with the matrix. All right. So if let's say I'm giving you this matrix, this vector. Let's say we have a okay. Let's say we have a vector v. And we have let's say we have a vector. Oh, sorry, this not should be like this. Should be. And this one we will take these two, and let's say this is 1 and 3. All right. Okay, so let's say we have this. Okay, let's say we have this vector, and if we draw this into a Cartesian coordinate, let's say this is our x and this is our y. Okay. Okay, so 1, 3 is, we can assume that 1, 3 is somewhere 1 and then 3 is somewhere here. So perhaps we can get something like this. Okay, 1, 3, somewhere here lah. Alright, this is 1, 3, this is V. Okay, and then we have also a matrix. Let's say we have a matrix A. Okay, we have a matrix A, and this matrix is 2, 1, minus 1, and 1. Okay, let's say we have this. And then, okay, we have this. And if we do this operation, if let's say we have another matrix, and this matrix, let's say this matrix V, this matrix A, not A, B is equal to A V. Alright, please remember this formula. Alright, so when we have this, then if let's say we have another vector B, and this B is equivalent, is equal to matrix A multiply with V, then we get something like this, and then Okay, and then when we do some operation here, then we will get 2 multiply with 1 plus 1 multiply with 3. Here we get 5, and here minus 1 plus 3 we get 2. So if this is our V, if this is our V, then our V, our B, our vector B is somewhere 5, 2, 1, 3, and then somewhere here, this one, 1, 3 perhaps, some like that, and then 5, 2 perhaps somewhere here. Okay, let's change the color to blue, and maybe this one we can change it to this one. Okay, so this one is vector B. Vector B. Okay, this is vector B. Alright, so basically when you see this Cartesian coordinate here with our x-axis here and our y-axis here, and we initially have only one vector, which is the V, and the V has coordinate 1, 3, and it's pointed in this direction. And then when we do the multiplications of this vector, the V vector with the A, okay, where this operation we can call it as manipulations. Okay, so we are actually manipulate the vector with the matrix, and we get another new vectors, which is the B. And if you look into this Cartesian coordinate here, you can see basically this one, I think it should be, yeah. Okay, for this one, you can see actually what happened here is there is a rotation, okay, rotation from V to B, one thing. And the second thing is, this is basically the position for the V. And actually there is another operation which is stretching. Okay, I repeat, there is actually an operations from V, from vector V to vector B, where you can see there is a first operation is rotation from V in this direction, we rotate it to this direction. Alright, and if we rotate this V, the V will be pointing somewhere here. Okay, somewhere here. And then the next operation is stretching, where we actually stretch the vector B so that the vector V, so that the new vector here is in this position. Okay, so even if you look into the coordinate position for the V and for the B here, for the V, the X location is 1, and for the B, the location for the X is 5. So basically, obviously, there is an stretch in this direction. Okay, so that will be the first elements for this one. So basically we can actually do two operations, okay, in order for us to get a new vector from the previous vector. Okay, so in this case we can say that we do the first operation, which is the rotation. Okay, which is the rotation. So the rotations, so for the first elements of the matrix A, so now we are changing. we have, for the first case, we have a finite numbers for the matrix A. So in the second case now, we are actually building a new factor for this matrix A. So in this case, we have the first one, which is the rotation, and the rotation is cos cos theta, and then the next one is minus sin theta, and then this one is sin theta, and then this one is cos theta. Okay, so this is the first operation, the first part. Okay, and also as I mentioned just now, this V can be, we can rotate this V. Okay, and then we will do the stretching. So for the stretching, we will have another matrix. So the matrix is still A, alright. And here we can include a new parameter here, which is, we can say, because we are doing the stretching. Oops. So this one, let's say we have alpha, and then 0, and here another alpha, and here is 0. Okay, so if let's say we are using the second parameter here for the stretching. This is for the rotation, this is for the rotation, and this is for the stretching. Right, so if let's say we are taking the first element here, the V, the V here. Okay, so let's say we have the V, and we do the same operation as this, but then we are using the stretching part. So let's say this one is for the, maybe I should like this so that easy for you. AR and AS. AR is matrix A for the rotation, and AS is the matrix A for the stretching. So let's say here we are using the AS times that one. So let's see this one, I change to C. I think C better. C. Okay, so let's see, we have that, and we let our alpha as 2, and then so what happens here is now our alpha will be 2. Oops. So now we will change the alpha to 2. Okay, 2, and then we will multiply with our V here, 1, 3. Okay, then we will get 2, 6. Okay, so in this case, the first matrix is 1, 3 here, and for the next one it is 2, 6. So the 2, 6 is basically we stretch the V 2 times. Okay, so here what happened here is we have this V, still in the same direction, but it is to 6. Perhaps it is a bit somewhere here. And then let's see, we change the color to this color. Okay, somewhere here. So now we have our C bar. By using a stretching, part, this one, the stretching, we can stretch our previous V vector to get a new vector C. Alright? Okay. So that will be a first case for the stretching. Alright. So the same thing actually, if you apply any theta number, you can assume, or you can let this theta to be 10 degrees or 5 degrees, and then you multiply this with this vector, okay, and you will get a new vector when the theta at that number. Or if let's say you are putting 10 degrees, the theta is equal to 90 degrees or 10 degrees, then you will see this vector V will rotate for 10 degrees from the initial position. Okay? Alright, so you can try to look at it later. So the next part, we will look into how this rotation can be applied on the circle. Alright?